Hey, and welcome to the second chapter of Python for AI development course by AssemblyAI. I am Musra Torp. Today I'm going to show you how to prepare your data for training a machine learning algorithm. And then in the next lesson, we're going to learn how to use scikit-learn library to train a machine learning algorithm. Today, I'm going to show you how to build this code on a Jupyter notebook. You already learned how to set up a Jupyter notebook on your laptop and also Google Colab. If you want, you can use Google Colab or Jupyter notebooks for this lesson. It's totally up to you. If you want to follow along with the course, I will leave a link to the code somewhere up here or also in the description, so you can go ahead and follow along as I also code here. On top of Jupyter notebooks, of course, we're going to be using Python, and mainly we're going to be using the Pandas library of Python to do our data analysis. What we're going to do is to explore the data, understand it a little bit better, and then we're going to deal with the problems in our data if we run into anything during exploration, and also prepare the data for model training at the end. I'm going to take a Kaggle dataset, the flights dataset that I will introduce to you in a second, and go through it as an example so that you can also follow along. So it's not only going to be theoretical, but you can kind of understand how it's also done in real life. But first I want to talk to you about the types of data. So if you're new to data science, if you're new to AI, it might be a little bit overwhelming to see what kind of data sets that are out there. Because your data set could be a tabular data, your data set could be images, your data set could be text files, or even audio files. So all of these different types of data sets will have a different way of dealing with them, a different way of exploring and cleaning them. But the beginner level is to kind of work with tabular data because it's more structured, it's easier to understand, and also it's a good way to get some experience before you jump into other types of data sets. So there are a couple of steps that you should take before you do any coding. And the first one is to understand where your data is coming from. So sometimes you download your data from the internet, maybe you download it from Kaggle, you download it from a university's research group, or maybe if you're working at a company, maybe you get it from another team. So one of the main things that you have to look for is documentation, because datasets are not always self-explanatory. There could be a column name that is abbreviated, there could be a column name that just looks odd and that you just don't understand. And you're not always the subject matter expert in the field that you're working for as a data scientist. So that's why I always look for documentation. If you're getting your data from Kaggle, there will be a website where you can see details for your data set. If you're getting your data from some other place on the internet, there's probably going to be either a TXT file or PDF file explaining to you how this data was collected, what each of the columns mean, what their units are. So let's say if it's a length column, is it in inches, is it in meters, or if it's a time column, is it minutes or hours? So these are really important things to know. If you're working with internal data in a company, or maybe you made the data, it is important to talk to the people who prepared the data and kind of understand how this data was collected. This will kind of give you an idea of what kind of problems to look for as you're doing your exploration. So it will be a little bit more efficient there. So let's get started. The first thing that I want to do, of course, is to import Pandas. And I'm also going to import NumPy because, you never know when you're going to need NumPy, which is more or less always. And I will also show you how to set up one of my favorite settings. So this is setting the Pandas option of display mux columns to none. So there are no limits of how many columns to be shown. And I'll show you why that matters in a second. Let me get my data set here. flightsample.csv. As I mentioned, I'm using the flights dataset from Kaggle. It has the information of delayed flights, but also non-delayed flights. And we're going to look a little bit more into detail, and I'm going to tell you what kind of problem I'm going to be solving with this example dataset. But just so you know, right now, if you download it from Kaggle, you will have a flights.csv, but I sampled fewer amounts of the data points from that big data set because it was a little bit too big to run as an example. So that's why mine is called flight sampled. I will read it into a flights variable. All right, and then let's see how many rows and columns this data set has, and that's you'd use the shape function for that. So it apparently has more than 1 million columns, a million rows, sorry, and 31 columns. So if I try to print this data set, what's going to happen is that it's going to show me all of the columns, but as you can see, it doesn't show me all of the rows. It's because there is a max rows limit. And if I also set the max columns limit, what's going to happen is if I try to run this, I'm only going to get 5 columns. So sometimes if your data set is really big and you're trying to print it to understand all the columns that are in there, it will not show you all of the columns. There will be a limit, and if you want to eliminate that limit, all you have to do is here to set display max columns to none, and then you'll be able to see all of your columns. If you want to see only a couple of data points, you can say data flights head, and then it will show you only the first 5 data points. Or you can specify how many you want to see, and then again it will show you the first 10 data points. So as I said, we're going to be doing data exploration today, but what does that exactly mean? So what we're going to do is to look for missing values. We're going to look for outliers. We're also going to make sure that our categorical values and binary values are consistent and there are no problems with them. And also lastly, we're going to look at column types to make sure all of the columns have the correct type. So if it's a number, it's a number. If it's a category, it's an object, as the naming goes in Python. Let's quickly take a look at our data set. We have, for each row, we have one flight. We have the time and date of the flight, which airline is running it, flight number, tail number, origin and destination, when it was scheduled to depart, when it actually departed, how long it took for the flight to arrive and the arrival location, when was the scheduled arrival, when it actually arrived, and the delay. And we also have the information of whether it was canceled, if it was canceled, why it was canceled, and also some reasons for delay. So today the problem that we're going to try to solve is trying to predict whether there's going to be a delay, and if there is going to be a delay, what it is going to be caused by. So as you can see, we have 1, 2, 3, 4, 5 different delay reasons here, and then we're going to change the dataset in a way that when we train the model, it is going to be able to tell us what is the delay going to be caused by. So it's kind of like predicting the future a little bit. But as you can see, there are a lot of columns here that maybe I will not really need as I'm doing exploration. So I'm going to remove a bunch of them. So I can use flights.columns to see all of the columns. And then I will only select a bunch of them. So if you use double brackets in Pandas, that means that you're going to choose a subset of your columns. So I will just copy and paste all of the column names here, but then I will only keep the ones that I'm interested in. So I want to keep year, month, day, day of week, airline, because you can imagine which airline is running the flight will affect whether this flight is going to be delayed or not. Maybe some airlines tend to be late more than the others. I don't really need the flight number because flight number is basically manifested in origin airport, destination airport, and scheduled departure and airline. Tail number I also don't feel like I need. But of course, these are decisions that you can undo, right? If you realize that you need some of the information, you can come back and change this. Scheduled departure, I don't really need the actual departure time. So when you think about it, what's going to happen is when this model will be used, it's going to be before the flight. So we will not have certain information like departure time or arrival time, arrival delay. So these are things that we will not have access to. So that's why I mainly want to keep information that I will already have at this point. Delay, well, yeah, here, one thing to be said about this is, if I have some missing information, maybe I will be able to use departure time, for example, to fill in those missing information. So I will actually keep departure time for now, also departure delay. I feel like taxi out, wheels off, scheduled time, elapsed time, these will not be really relevant, so I will remove those. I think scheduled time, scheduled arrival and arrival time will definitely be helpful. Arrival delay is exactly what I need. I will also keep canceled and cancellation reason, and also all the delay reasons for now. So let's take a look at our data set again. All right, these are the only ones that I want so far. I will immediately take a look at whether there are any missing values. So let's take a look. Okay. So it looks like there are a bunch of missing values. We are missing departure time and departure delay sometimes. arrival time sometimes, arrival delay also, cancellation reason, which makes sense because, you know, we probably many of the flights are not canceled, so that's why there are no cancellation reason. But interesting thing is we do not have a delay information most of the time, but there's the equal amounts of time. So this could be that maybe it's not a missing value, it's just that because the flight was not delayed, this information is empty. So to understand whether that is the case or not, I want to see what happens every time arrival delay is non-existent or 0. So I'll say flights. Let's see, when arrival delay is missing, we are also missing these guys, which makes sense. Okay, but of course this is only, let's say how big this is. This is only, yeah, 7,806 times. And delay reasons are missing more times. So let me see whether these reasons are missing all at the same time. This could just be a coincidence that these numbers are the same. So just to save you some time, I made this, prepared this code from beforehand. So basically I'm saying, show me all of the rows where air system delay is null, but also security delay is null, airline delay is null, late aircraft delay is null, and also weather delay is none, another number. So I will call these null values. And let's see how big it is. Oops. All right, so that is 354,479 times, which is actually exactly how many times we have missing information here. So this means basically that every time air system delay is null, all the other delay reasons are also null, and they're only null when the other ones are null or none or another number. So this is good to know. But one thing that is interesting is then I would have expected arrival delay to also have the same amount of none values. So maybe let's put this on a histogram, and then it will be clearer to see what's missing exactly. All right, so this is a histogram of when air system delay, security delay, airline delay, and late aircraft delay are none. And we see arrival delay actually starts from -60 or -80 and goes only until like 10 or 15, which is interesting. And let's take a closer look here. I want to see every time arrival delay is bigger than 10. Okay, arrival delay is 14, 15, but these all look like very small numbers. What if I say arrival delay is longer than 15? Oh, interesting. So we do not have any data points where when delay reasons are none, arrival delay is longer than 15 minutes. What about 14 minutes? Still nothing. 13 minutes. Okay, there is something. So this basically tells me that when arrival delay is shorter than 15 minutes, the plane is not counted as late. And that's why there is no delay reason given. This could be an interesting system. If I worked in the company, or maybe if I worked in the field, I will probably already know this. But this is something that you can learn when you're working with the data. So this is good to know. Then I will from now on think that only flights that arrived later than 15 minutes compared to their scheduled arrival time will be counted as late. Okay, so this is interesting information, but I also want to see why sometimes the arrival delay is missing. So let's take a look at this again. We see here arrival delay is missing, but yeah, for some of these, either we are missing the arrival time or we are missing, even though there is scheduled arrival information and arrival time information, we are still missing arrival delay. So I will set aside some of this data to kind of see, to be able to look at it more clearly. So I will say give me all of the data points for arrival delay is none, and I'll say arrival none for that one. Let's take a closer look. Oops. So what could be the reason? Oh yes, so it looks like maybe most of these are canceled. That might explain why we have none as arrival time here, but it does not explain these cases. So let's see how many of them were actually canceled, how many weren't. Okay, a good amount was canceled. Maybe a better way of actually showing this could be to use value counts. Value counts would tell me how many times these values, these data points where arrival delay is missing, the flight was canceled or it wasn't canceled. So, okay, it looks like sometimes it was canceled. Well, most of the time it was canceled. Only 1,000, a bit more than 1,000 of the cases it wasn't canceled. And we see two examples here. So there are a bunch of ways how you can deal with this. If you remember, what we're trying to do here is to estimate or predict why a flight was delayed. So here we see clearly this flight was supposed to land in 2026. If you are watching from the US, you might not be familiar with this. Basically, it means 8:30 p.m., 8:26 p.m. But it landed at 10:16 p.m. So there is 1 hour, 50 minutes of delay there. But we do not have the delay information or why it was delayed. So what we could do here is to calculate the arrival delay. So if we were building a model where we were trying to predict how long of a delay there is going to be, we could have definitely used these two columns of information to calculate arrival delay, but we're trying to predict the delay reason, and we cannot generate the delay reason information with what we have. So here what I'm going to do is, because we have more than 1 million examples, more than 1 million data points, and this information only covers 1,000 of them, I'm just going to delete them. So it's easier for me to work on my data. There's not going to be any dirty data in there. Anyways, I cannot use this information at the end of the day. So what I'm going to do is to say flights, remove the ones where arrival delay is none. So basically what you do here, you create a filter. You say every time the arrival delay information in the flights data set is null, and by using this tilde, you're negating it. So you want all the data points from the flights data set where the arrival delay is not missing. So let's do this. And then I will also want to see what the shape of my data set is. So right now it is 1,410,112, and before it was again 1,417,000. So there is not a big difference, and it's a good thing that we deleted those. And we deleted these ones because we cannot use them, and we also deleted the ones that were canceled. Again, we cannot use them; they were canceled flights. All right, let's see what kind of missing information I have left in my data set after this action. All right, we do not have any arrival delay missing information left yet. Cancellation reason, as I said, is expected. And we have the delay reasons still as missing information. So what I can do actually is to just fill them in as 0, because we saw that only time where these values are missing is when there is no delay. There are sometimes some arrival delay, less than 15 minutes, but these flights are not considered late flights. That's why there is no reason for delay. So that's why I'm going to go and fill this information in as 0. How I'm going to do that is by saying flights, specifying which columns. I can just copy and paste the names here, a bit easier. And I will use a fill na function, and I will specify what I want them to be filled with. So this is the information that I will get back, but instead of this, I will just equate my columns to what the function is going to return. And then when I check my flights data set again, you will see that what used to be na will be 0 now. All right, so it looks like I'm more or less done with missing information. As I said, I do not need to deal with the cancellation reason one because it will not make its way to the model training phase. I will remove it before then. So then I want to see if there are any outliers in my data. And to do that, using histograms is a really good way. And I will show you how to read histograms in a second now. I'm just setting the bins to be 60 and the figure size to be 20 to 20, so we have a bigger canvas so we can see all of the little histograms a little bit better. And what bins means is basically the more you increase this number, the more granulated information you're going to see. If I'm going to set the bins to be 20, then the granularity of the information is going to be lower. That's why one number that I like to use is 60, but depending on the data set that you're working on, you might need to change that. All right, so let's take a look to see if there is anything interesting that's going on that's not expected. So I only have flight information from 2015. This is expected. Months, these are the amount of flights that I have each month. So for the first month, I have more than 120,000 flights, and the other ones are kind of similar, more or less expected. Day of the month, we see a little pattern here. Day of the week again, with the numbers are from 1 to 7, which is expected. And yeah, we see that maybe on Mondays and Thursdays there are more flights. Scheduled departure, departure time, departure delay looks normal. Scheduled arrival looks normal. Arrival time looks normal. Arrival delay, again, sometimes there are minus delays. That means the flight arrived earlier. Sometimes it looks like it's longer. One thing that you need to pay attention to when you're reading histograms, though, so let's just iterate what this looks like. So it basically tells you for each value of these columns, how many times this value occurred. So if, let's say, this high number is 0, that means arrival delay has been 0 for more than 600,000 times in this data set. And the higher the value, the less occurrence that you see of these values. But one thing that also you need to understand is histograms only show you the values on the x-axis that exist in your data set. So if it shows you here 2000, it means that there is actually a value that is 2000 or maybe a bit less than 2000. So that's why I want to go ahead and see if that is an outlier or not. I want to see if it actually makes sense that there is an arrival delay for 2000 minutes or hours. So let's take a look. Delay. Let's take a first look at like more than 500. So I have a bit more than 2,000 data points where the arrival delay is higher than 500, and it looks like this actually makes sense. So this would say arrival time was 12:28 and the flight actually arrived at 8:54, so that's why there is a big delay. Or the flight was supposed to land maybe the day before at 10:56, but it arrived at 7 in the morning, 7:44 in the morning. That's why there is a big delay. And for all of them, we do actually have a delay reason. So let's quickly check. This one is this. So this looks legit to me, but also let's look at very big delays. Okay, we only have a handful of these. Arrival delay, arrival time, but it looks like all of this information is actually checking out. So let's see, this flight was supposed to land on 10:49. It arrived, well, it looks like 4 hours, but maybe it's actually the day after 4 hours, the day after at 2 p.m. So maybe that's why there is a big delay there. And we also have this delay attributed to a reason. So it looks like there is not actually a problem. It's just some flights are actually super, super late. Okay, that's good to know. What else can I look at? So do I have all of my delay reasons? I have air system delay here. Some of them are really long. Security delay, airline delay, late aircraft delay. But as you can see, I do not have a plot for weather delay. And that could actually point to something. So let's look at what my flight column types are. And I can use D types for this. All of these delays should be numeric, but I see weather delay is object, and object in Python basically means string. And that means there is a problem with weather delay. So it could either be that when I'm reading the CSV file, there was a little problem and Pandas was not able to read it properly, or maybe that might mean that there is a value in there that cannot be cast to integer. That's why Pandas read it as a string. So what I'm going to do is to try to turn this value or this column, weather delay, into a numeric column, and let's see what happens. PD2 numeric is what I'm going to use. I'm going to pass the column. All right, we get an error, and it says unable to parse a string dash at position 107. So let's go to position number 107 and then see this, what's going on. I'm going to use iloc, so the location where the index is 107. And this is the row, this is the flight. And I see that weather delay is indeed dash. So when this happens, you have a couple of options. You can either change this one manually, go ahead to your data set and literally change this one manually. You can change this one by writing a line of code here. Or what I like to do when I see these little stray characters here and there, if there are not a lot, I will actually go back to when I read my data set, and you can specify what values should be considered as missing. So here I will just also include dash as a missing value. So if I run this, and if I basically run everything that I ran so far, let's see. If I get a plot for weather delay, which I did, that means that it worked. So basically it counted the dash value or values as none, and then it was cast to 0 probably. So now I am able to see weather delay here listed in the plot, in the histogram, and yes, the type is float. So that's also correct. So I do not have to do this again, or this one. I'll just comment them out. So far we took a look at the missing values and the outliers, and I was keeping some of the extra columns to help me realize or decide what to do with the missing values and the outliers, but I don't really need them anymore. So just to make life easier for me, I'm going to remove some of these columns. So I'll just again print all of the columns here and then choose the ones that I want to go forward with. So let's select these ones. I still want year, month, day, day of week, airline, origin, airport, destination airport, scheduled departure. I will not know departure time when time comes to use this model, so I will remove that. Departure delay, scheduled arrival, I will know that. Arrival time, I will not know. Arrival delay, I will not know. Canceled or cancellation reason, again, I will not know. But I will keep the reasons for the delays for now because I'm going to use them to create a target variable. But this is just a quick cleaning to make life easier for me. All right, so now it's time to look at the categorical variables. Let me just look at the types of my columns again. Most of them are integers and float, that means they're numeric, but I have 3 that are categorical. So let's take a look at the airline one. I want to see what kind of names there are for the airlines. Airline. And what you can use for that is value counts. It will show you how many times each value occurred in your column. It's basically a histogram in a table format. So we see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 different airlines. And yeah, they seem to be more or less evenly distributed or represented in the data. So what if I look at origin airport? All right, I have a lot more information here. Let's see how many different origin airports we have. 922. What about destination airport. 921. Okay, so this actually is a lot of data, and it's because it's categorical, it might overwhelm the model that I'm training at the end of the day. So for now, I think I will opt for removing these also from the data that I'm going to feed to my model. And I'm just going to try to estimate what kind of delay, whether there's going to be a delay and what kind of delay there's going to be, only using the time, day of the week, and the airline information for the flight. And also the scheduled departure, of course. All right, now that we took a look at this too, it is time to calculate our target feature. So the target feature is going to be a column that is going to have the information of which of these delays caused the actual delay. And if there is no delay, it's going to say no delay. So there are a bunch of ways how you can achieve that. What I'm going to do is I'm going to sum all of the delay reasons to see whether there's a delay to begin with or not. So I will create a new column that will say all delay. And then I'm going to get all of the delay reasons. Not there, but here. And then I will sum them up and make sure the axis is 1. So it's on the row level. And then let's print the flights dataset again to see if everything worked well. All right, so this is 0. All delays is 0. Here is 25 because all of this summed up is 25. The other ones look correct too. Well, you might say, Mustafa, why are you not using the arrival delay, which I removed already, I think. It's because, remember, that one sometimes is minus, but that one sometimes is, if it's lower than 15, the flight is not counted as late, so then I will not have the correct information. So that's why I only use the delay reasons information here. So next what I'm going to do is I'm going to actually use NumPy, the where function of NumPy. Here what you do is you give it a condition, so where you want to do some changes. And if the condition is met, what do you want to name, what do you want to return as a value? And if the condition is not met, what do you want to return as a value? So what I'm going to say is if flights all delay, not with a capital D, is greater than 0. So if there is a delay, I want the name of the cause of the biggest delay. So we have the air system delay, security delay, airline delay, late aircraft delay, weather delay. And here so far we've seen that only one of them causes a delay, but it could be that more than one of them causes a delay. So maybe this air system delay causes a 25-minute delay, but airline delay causes a 1,000-minute delay. So that's why then I would want to mark airline delay as the actual core reason of this delay. So that's why I'm going to get the maximum value. But if you only do max, you will get the number. But I don't want to get the number. I want to get the name of the column that includes the highest number. That's why I said IDX max, and again, axis 1. So this value will be returned if the all delay value is higher than 1. And if not, no delay will be returned. And I will assign this to a new column, and this column will be called delay reason. Let's print our data set. All right, so we see no delay here because all of the delay reasons are 0. Air system delay because it is 25. Airline delay is 156, so it looks like it worked. I just want to see if they are distributed evenly. Delay reason, value counts. Okay, we have late aircraft delay is the biggest reason. Sometimes there is no delay, and security delay does not happen very often apparently. And remember, we assumed that if there is delay that is less than 15 minutes, it is marked as no delay. So let's make sure that we also captured that assumption here. So if delay reason is no delay, I want to see what the values of arrival delay is. Oh, did I remove that already? Scheduled arrival. Oh yeah, I shouldn't have actually. So yes, I did remove it, but I fixed it now because I want to take a look at the statistic, but maybe in a histogram it will be shown nicer. Okay, so I see when the delay reason is stated as no delay, arrival delay only goes up to like 15, 10 to 15, which is perfect, which is that's what we've seen. All right, so now it's time to actually clean my data and not leave anything that I do not want in there in terms of columns. I'll just copy this. Or maybe I need to print the columns again because I think I changed some things. So the columns I have right now are these. And the columns I want are year, month, day, day of week, airline, scheduled departure, scheduled arrival, don't want arrival delay. I don't want the delay reasons because I have them in delay reason, so everything else can go. So this is my data set. And before we jump into making the model, I want to make sure my training data is ready. So if you never trained machine learning models before, this might be new to you. When you are training a machine learning data set, you give it the X values, which is the information you will feed it to. Separately than the Y values, which is the information you will receive from it. So that's why we separate our data set now to X flights and Y flights. The X value is going to have everything except the target value, so the value that we're trying to estimate. And Y flights is going to have only the delay reason, but still in a dataset format. If you use two brackets, it's going to return to you a dataset. If you use one bracket, it's going to return to you a series object. A series object being one column or one row. And let's see what this looks like. X flights and then Y flights. And before we jump into model creation, one last thing that I want to do is to create one-hot encoded features columns from my categorical value. So let's look at X flights again. The only categorical value we have is the airline, and we want to do one-hot encoded information from this because otherwise we cannot feed it to our machine learning model. Machine learning models are, at the end of the day, mathematical models, and they need to, or they can only handle numerical values. So we have year, month, day, day of the week, scheduled departure and scheduled arrival as numerical values, but I also need to have airline as a numerical value. What I can do for that is to use Pandas get dummies function, and then I will pass the X flight dataset in there fully, and then I will receive the one-hot encoded version for the categorical value. So let's run that and then see what it looks like. All of the numerical values are the same, columns are the same, but the categorical column is separated into however many values there are in this data set. And if the airline is DL, let's say this is Delta, it is 1, and everything else is 0. So this makes it possible, one-hot encoding makes it possible for us to feed our data into the machine learning model, which we're going to do in our next lesson. So if you're come this far, congratulations. Don't forget that you can get the code through the link somewhere here or also in the description if you want to follow along. But from now on, we're going to jump to the next lesson where we're going to train a machine learning model on this data using scikit-learn.